Hi everybody, welcome back. In this video we're going to talk about function parameters, or maybe families of functions, because when it comes to machine learning models or artificial intelligence, you might already have heard about the weights of the model, and that is exactly what we're going to be discussing here. I wrote down 4 functions here, and for example f of x is 2 times x plus 1, and so on and so on. And what you can actually see that these are all polynomial functions. Well, the first 3 here are just polynomials in one independence, and of course you can also form polynomials with multiple independents, for example k of 3 independents x, y, and z. And we're going to focus here a bit on those first 3, and actually with every n plus 1 tuple, let's say a0, a1 to an, in Rn, r to the power n plus 1, you can make a polynomial function. You can make a polynomial function, let's say f from R to R, which maps x to a1 x to the power 1 plus an minus 1 x to the power n minus 1, and so on, with a1 x plus a0. Often you use this symbol sigma to make our lives easier, and just denote this by ai x to the power I, which is a lot shorter anyway. And so what we can actually also consider is this giant function, big f function, where we go from r to the power n plus 1, product with r to r, which maps such an n plus 1 tuple, comma, a certain point x, to exactly this sum. And so basically, if you're going to say we're going to deal with here polynomials in one independent of degree at most n, then we can actually consider this as a big function, and whenever we specify a certain n plus 1 tuple here, then we have fixed our polynomial. And let's make this a bit more concrete by looking at an easy example where n equals 1. So how can I write this big function f now here? So we're actually working in there. R squared is product with r to r, and I'm going to send the tuple with x to m times x plus q. And if you have studied a course on linear geometry, then you know that these functions mx plus q, they give the equations of lines. So, for example, we're working here in the plane, and we can actually draw the line, for example, this line here. This corresponds to m equals 1, q equals 0, or we can specify here if it goes to 1, something like this. We can say q equals 1 and m is equal. I drew it a bit more steep than the other line, so this will probably be something like minus 2 or something. So what you can see is that, okay, let's say I want to make a function which is a line in the plane. Then all I actually have to do is specify this m and this q, and then we can actually say that m and q are the weights of our function f. This idea will elaborate more. I can say this again. So let's say you want to make a function with the graph of which is a straight line in the plane. So basically you have to somehow determine this m and this q, and we're going to see how we are going to determine this. And for this reason, because with every choice of m and q we get a different line. For example, if m is 1, q is 0, we get this line, we can have this line, we can have all the other lines. These are all lines that you can draw. And that's why in our model we're gonna have to somehow determine this m and this q, and that's why we actually say that these are the weights of these functions. Ciao.